Welcome to Fast Math Solution on Maths with EJD. In this video, we'll be looking at an application of geometric sequence in pharmacy, talking about dosage reduction over time. So a pharmacist is preparing a medication where the dosage needs to be reduced every 4 hours by half. So after we see that every 4 hours, after every 4 hours, okay, we have the common ratio is half. So the dosage will be reduced by half. So 4 is important because that is going to give us some idea. All right. Then the initial dosage of the medication is 100 milligram. That means that A, which is initial dosage, that's the first term, initial dosage is 100 milligram. Okay. That's the first term. The dosage for the next few intervals will follow a geometric sequence. All right. I mean, it will be halved, right? So that's geometric sequence automatically. So we have to answer these three questions. What is the dosage of the medication after 8 hours? Okay. Um, in that case now, it's after every 4 hours. So I think one easy way we can do this is like this. We can actually say at the 0th hour, right? If you like, you can say at the 0th hour, we have 100 milligram. Okay. Then after that, after 4 hours, we have 50 milligram. Okay. So this is this is second term. Or better still, I think it's better to say this is N1, okay, and this is N2. Is that how we say it? This for this place, N is equal to 1. Yeah, I think that's more like it. And here N is equal to 2. So we know that the next one is 8 hours. So that will actually be where N is equal to 3. So I think that's more like the idea we need there. So of course, although from here we can already get that, like we know after 100 milligram after 4 hours again, it becomes half. So that's 25 milligram. So we can do it straight like this because I mean this is already the answer without even doing so much. But then if you still, in case it's something long away, it's still a long way off. So you need to so this interval is necessary because of the 4 hour involved, since we can't just jump straight. So we need to know the point at which we have 8 hours. But I mean, since we know eight is at time point 3, so to speak, it means that we simply need we need the let me say the question again. It says, what is the dosage of the medication after 8 hours? Okay, the dosage after 8 hours corresponds, actually corresponds with T3. So we need T3. And for a geometric sequence, for a geometric sequence, okay, um, Tn normally is AR raised to power n minus 1. So here we already have A to be 100 milligram. We have common ratio is half. And here n is equal to 3 because it's the third term. So we can say, therefore, T3 is equal to 100 times 1 over 2 raised to power 3 minus 1. Okay, so T3 now is equal to 100 times 1 over 2 raised to power 2. So that is T3 equals 100 times 1 over 4. And that gives us the 25 we already got, right? 25 milligram. So the therefore the dosage after 8 hours is 25 milligram. I mean, that's too easy to get. So we didn't need to use this formula again since we could get it straight. But take it like you have two methods to get the same result, basically. All right. So the next question says, what is the dosage of the medication after 24 hours? Now, after 24 hours, so what does N correspond with? Um, after 24 hours, let's see. So we can take this further. Uh, 8, then you have another 8, another 4, right? That's 12. That means n is equal to 4. Okay. Another 4 hours will take us to 16, where n is equal to 5. Another 4 hours will take us to 20, where n is equal to 6. Then another 4 hours will take us to 24, where n is equal to 7. Okay. So to find it, we need to find the dosage of the medication after 24 hours. So to find the that's number 2 now. Here this is 1. So now we're talking about number 2. So to find the dosage after 24 hours, the dosage after 24 hours, which is T, yeah, after 24 hours. So this corresponds with T7, okay? Because starting from the beginning, 0, 4, and all that, it takes us to the seventh element, the seventh term of the geometric sequence, right? So that now we have again, you can remind us that I mean Tn is equal to AR raised to power n minus 1. So here n is 7. A again is 100 milligram where we are given initially, and R is half because it keeps getting halved like that. So we have T7 is equal to 100 times 1 over 2 raised to power 7 minus 1. So that means that T7 is 100 times 1 over 2 raised to power 6. Okay. Um, raised to power 6, right? Then we have T7 equals 100 times 1 over 2 raised to power 6 like this, because 1 raised to power 6 is 1. So, well, 1 raised by anything is 1 actually. So 100 times 1 over 2 raised to power 6, that's 2 times 2, 4, 4 times 3, 8, 8 times, 2 times 2, 4, 4 times 2, 8, 8 times 2, 16, 16 times 2, 32, 32 times 2, 64. So this whole thing is actually 100 divided by 64. Okay. And if you do that division, right, T7 is equal to 1.5625. So you can say, therefore, the dosage after 24 hours is 1.5625 milligram. And that goes. Now we have the final showdown, which says to find after how many hours will the dosage be reduced to less than 1 milligram? Okay. So after how many hours will the dosage be reduced to less than 1 milligram? Okay. So now to find to find to find the number of hours, the number of hours after which the dosage will be less than 1 milligram. That means we need the point where Tn is less than 1. Basically, that's what we need now. All right. So, and we already know Tn to be AR raised to power n minus 1. Now that will be less than 1. Okay. So that means that, of course, we already know A is 100. R is uh R is half. Now we need to know n. Once we know n, that can now help us to know the number of hours. So it talks about the time steps, right? So in this case, excuse me, so we have so this now becomes like 100 times 1 over 2 raised to power n minus 1 is less than 1. So that's the system we have. And to make things easy, we can divide both sides by 100. So we have half raised power n minus 1 is less than 1 over 100. Okay, like that. So we have half raised power n minus 1 less than 0.01. That's what 1 over 100 is. Now, because we have power attached to this, right, the best way to remove power is to take the log of both sides. We can take the natural log, which is ln 1 over 2 raised power n minus 1, and that is still less than ln of 0.01, right? And then because of from the law of logarithm, this power can come down. Okay, this power can come down. So we have n minus 1 into ln 1 over 2. Okay, ln 1 over 2, and that is less than ln 0.01. Then we know n minus 1. Ln 1 over 2 is ln 0.5, and ln 0.5 is simply minus 0.6931 if you punch your calculator for that, or you check a table, and that is less than ln 0.01. So now, okay, well, I think at this point we can get what that is. Ln 0.01 is approximately um minus 4.605. If you punch your calculator for that, you get that. Minus 4.605 minus 4.605, so that we can divide both sides by minus this now. So now when you divide by negative sign for inequality, the sign changes. So you have n minus 1 is now greater than, okay, I guess I want to change the marker color here to know that we are doing something strategic there. N minus 1 now will be greater than minus 4.605 divided by minus 0.6931. Now, at this point, because we are dividing by negative sign, the inequality changes. And if you punch your calculator for this, you get n minus 1 greater than. If you punch your calculator for this now, you get, I think, that should be roughly 6.64. Okay, that is right. Let me just be very sure of that. 6.64. But let me be sure. Minus cancels automatically, so that becomes positive. So we have 4.605 divided by 0.6931. 0.6931. So that is 6.64, right? 6.64. So that means that n is now greater than 6.64 plus 1. So n is greater than 7.64. So if n is greater than 7.64, I think it's safe to say n can be, I mean, the next integer after the next 4 hour, the next if you round this up to the next multiple of 4, so you can say that n is approximately 8. So that means that this is happening at n equals 8. So what that simply means is this. Don't forget that imagine when n is, okay, let's do it this way. I'm thinking of a very nice way. Okay, imagine n is here, and then you have the dosage. Um, thinking of a very nice way to do this. Okay, let's talk about the n, or let's talk about hours, right? Let's talk about the hours. Uh, okay. I'm thinking of a very good way to do this. Let's talk about n and talk about hours. I think that's a better way to go. So after 4 hours, okay, at 0 hours, right? N is 1. Yeah, I think this is fine. Then after 4 hours, we know that n is 2. Then after another 4 hours, making 8, n is 3. After 4 hours, that is 12, n is 4. After another one, after 4 hours, that's 16, n is 5. After 4 hours, that's 20, n is 6. Don't forget, we are looking for n equals 8, right? So we're almost there. So after another 4 hours, that is 24, n is 7. After 4 hours, that's 28, and n is 8. So, and the n we have is actually approximately 8 because the n is greater than 7.64. So the value of 8 corresponding to that, right, would be 28 hours. Okay? That'll be 28 hours. So we can now say, we can conclude then. Can I write that better? Okay, I think that's fine. So we can conclude that we can say, therefore, the dosage, the dosage reduces, the dosage becomes less than 1 milligram around or uh around 28 hours, around 28 hours after after the first use, around 28 hours after the first use, something like this. Yeah, so that goes so 0, 4, 8, 12, 16, 20, 24, 28. That's 1, 2, 3, 4, 5, 6, 7, 8. That works like that. So I still have more of this coming. So subscribe to the channel, hit the notification bell so you can always get alerted each time a new video is released. I think in the next one I'll be talking about a binomial series or something close to that. Then, of course, comment, let me know how helpful this video is, and let me know if there's a topic you'd like me to teach or a problem you'd like me to solve, and like and share so that more people can have access to this great learning. Bye.